Hi guys, welcome back to Brilliant Qatar. Here we're discussing the questions. Identify the compounds A, B, C from the chapter Alcohol, Phenols and Ether. Dear all, haloalkanes and haloarenes, these type of questions already we discussed. Please get into our YouTube channel. It is available there. Here we are studying alcohol, phenols and ether. Identify the compounds A, B, C by giving a paragraph or an equation. They ask this type of questions. Are you ready to discuss the question from the chapter? Right? Question number 1 for you. A compound A, whenever these type of questions comes for your board exam, please make a pattern first, right? A compound A is a primary alcohol, all right? It's a primary alcohol with molecular formula C3H8O. When it react with PCl3, forms compound B, and B on reaction with sodium tert butoxide. What is sodium tert butoxide? NaOC CH3, or you can write NaOC CH3 thrice. Sodium tert butoxide forms compound C and identify the compound A, B and C. Simple question. See all, C3H8O, total 3 carbon and it is a primary alcohol. So what is alcohol? Propanol, right? 3 carbon primary alcohol is which one? Can be propanol. So propanol when react with the PCl3, what happened here? PCl3 convert alcohol to what? Cl. So we get CH3, CH2, CH2, Cl. You will get chloropropane. Ready? What happened? Haloalkane react with the sodium alkoxide. Williamson ether synthesis. So what happened? The Na and Cl cut will join. You get CH3, CH2, CH2, OC, CH3 and then CH3. You will get an ether. So the compound A is which one? Propanol. Compound B is which one? Chloropropane. 1 chloropropane, and this is what the ether forms. Ready all? So this is the compound A, B and C. Let's go for the second question. Compound A react with methyl magnesium bromide. That is our Grignard reagent. Methyl magnesium bromide followed by acid hydrolysis gives tert butyl alcohol. All right, tert butyl alcohol. What is that? Tert butyl alcohol. Dear, I'm starting from A. I got it. What is mean by A? How it is? We know this is a Grignard reagent. Grignard reagent, when react with a ketone, then you will get a tertiary alcohol. What is the idea? Grignard reagent, whenever you treat it with a ketone, you will get a tertiary alcohol. Alright, tertiary alcohol. So what is this ketone? I will say it's propanol. Why? Total our product contains 4 carbon, 1 carbon already there in our Grignard reagent. So remaining 3 carbon is from our ketone. So what is a ketone? Propanol. CH3COCH3 dear. Let me treat with the CH3 MgBr. Can you tell me what going to happen there? What going to happen there? Mg charge, you know, plus, and carbon charge is what? Minus, and the nucleophile attack on carbon, O become O minus. To the O minus, who will attack? MgBr will attack. So we get the product as CH3, CCH3, CH3, O minus MgBr. Followed by acid hydrolysis. What happen if you add water, dear? Water contain H plus and OH minus. So H plus come to this side, OH come to this side. We get CH3C, CH3, CH3, OH. We get tert butyl alcohol. Okay, so A is what? Propan 2 on. Ready? Next one. Which on heating with the H3PO4 at 358 Kelvin. Yes, since it is a tertiary alcohol, you know what is a dehydrating agent, right? H3PO4 at 358, that is dehydration. What do you mean by dehydration? Removal of water. So OH, let me take from here. Hydrogen take from any of the carbon. We'll get a double bond here. We get CH3, C double bond CH2. Then we have CH3. This will be the product. Yeah, you will get 2-methyl propene, you will get it. So that is a compound. So that's on gives compound B. So this is our compound B. Ready? Compound A on reaction with compound A. What is compound A? Propanol. Compound A on reaction with NaBH4. What is NaBH4? Sodium borohydride. That is our reducing agent. You know, ketone on reduction we get secondary alcohol. So CH3, CH, OH, and then we have CH3. And this is the compound C. Okay, it's compound C. Identify the compound A, B, C. Ready all? So compound A is propanol, compound B is 2-methyl propene, and compound C is which one? Propan 2-ol. Let's move to the third question. When isopropyl benzene, how many of you remember what is this compound here? Isopropyl benzene, that is our, the compound you studied that, cumene, right? Cumene, you know, isopropyl group when comes on benzene ring. What do you call that? Cumene. Cumene react with O2 followed by acid hydrolysis. So O2, you know, cumene on oxygen, reaction with oxygen, what you get here? Cumene hydroperoxide. Am I right? We'll get OOH, right? Cumene hydroperoxide. Followed by acid hydrolysis, what do you get? Phenol. You get what? Phenol and acetone. You studied that. This is the commercial preparation of which one? Phenol, industrial preparation of phenol from cumene. Next. So this is the compound A, all right? A. And compound A on Reamer-Tiemann reaction. Yes, phenol on Reamer-Tiemann. What do you mean by Reamer-Tiemann here? Aqueous NaOH and chloroform, then NaOH and acid. You know the reaction, right? On Reamer-Tiemann, what is the product? You know, we get salicylaldehyde. We get salicylaldehyde. Phenol on Reamer-Tiemann, we get salicylaldehyde. That is a compound B. Ready? And B on reaction with the HCN. Yes, what happen if you react with the hydrogen cyanide here? What happened? Come on. You know, H plus is there, Cn minus is there. Nucleophile. Who is the nucleophile? Cyanide. This reaction we studied in our aldehyde chapter. So Cn will attack on C. O become O minus. To the O minus, H will attack. So we get benzene with what? OH. And then we have CH, OH and Cn. We get cyanohydrin. Alright, so that is a compound C. Ready? And compound C undergo complete hydrolysis. What happened? This compound undergo complete hydrolysis, dear. On complete hydrolysis, we studied cyanide become carboxylic acid. Cyanide become carboxylic acid. So here OH and CHOH, and here we have COOH. We'll get this one. Okay, so this is the compound D. So these are the compound A is okay. A is phenol. Yes, B, C, D. Clear all of you? Next question for you. The compound A react with the CH3. React with the CH3CO twice O. What is this? What is this? This is our acetic anhydride, right? Acetic anhydride forms acetyl salicylic acid. Do you remember what is the structure of acetyl salicylic acid here? We'll get OCOCH3 and COOH. This is our acetyl salicylic acid, also known as what? The aspirin, the medicine. We know aspirin, how we prepare. Aspirin we prepare from salicylic acid. So A is our salicylic acid here, salicylic acid. We studied salicylic acid when react with acetic anhydride, we get aspirin. Ready? So A is what? Acetyl, that is salicylic acid. Form a salicylic acid. When A react with, okay, when A react with the zinc dust, what happen? When phenol part becomes what? Benzene, right? Zn take this oxygen. So we get what? Just only COOH is remaining there. So benzoic acid is the compound B. All right. Next, what's happening there? What's happening next? Compound B react with the sodium. What happened? Compound B when react with the sodium? Come on. What happened? Compound B react with the sodium. Acid when react with the metal. What form? Salt. The sodium replace this hydrogen. We get benzene with the what? COONA. Sodium benzoate. Okay, so that is when C react with this compound. This is B and this is what? C. Sodium benzoate is C. When C react with the soda lime, what is soda lime dear? NaOH and CaO and heat. When sodium salt of a carboxylic acid when react with the soda lime, we get what? One carbon less, the alkane. Here is what happened. Benzene forms. Because the carbon dioxide, the decarboxylation part is left. What is we get? Benzene. Byproduct is Na2CO3. So this is what your compound D. And identify the compound A, B, C and D. Clear dear? So first one is salicylic acid on acetylation, we get aspirin. And on reaction with the zinc, phenol become benzene, and on acid when react with the sodium we get sodium salt of acid. Sodium salt of acid with the soda lime we get the product, one carbon less. Okay, next question. When methyl magnesium bromide, right, Mg plus and this minus. Methyl magnesium bromide react with the compound A, followed by acid hydrolysis form third butyl alcohol. Already we discussed this compound in another way. So I am not repeating again dear. Hope you remember what is this A. A should be a ketone. Whenever a ketone react with the Grignard reagent, we get this alcohol. So what is this ketone? This is our propanol, right? Propanol. A is propanol. Ready? Next one. When the product so this is the product, right? When this product react with the copper at 573 Kelvin, what is that? We know copper at 573 means it is an oxidizing agent. But tertiary alcohol we studied, they do not undergo oxidation, instead it undergo dehydration. What is dehydration? OH and H cut. So we get CH3C, CH3, double bond, CH2. We will get 2-methyl propene. Ready? So this is A, this is our compound B. Next. B react with HBr. B react with HBr in presence of peroxide. B react with HBr in presence of peroxide. Form C. What is in presence of peroxide? Anti-Markovnikov's rule. Negative part goes to carbon with more hydrogen, and H plus goes to less hydrogen. We get CH3, CH, CH3, and then we have CH2Br. And this is your compound. This is B. It is C. Identify the compound ABC. Clear all? So remember this point. Whenever a Grignard reagent, if you treated with a compound, if you are getting a tertiary alcohol, and then the compound should be a ketone. Here already 1, 2, 3, 4 carbon in product. So 1 carbon already there in your Grignard reagent. So 3 carbon is in our ketone. Ready? So ketone is propanol. And tertiary alcohol do not undergo oxidation with oxidizing agent. Instead it undergo dehydration. And HBr with a peroxide means what? Anti-Markovnikov's rule. So negative part goes to carbon with more hydrogen. Positive part goes to carbon with less hydrogen. Clear dear? Next question. This way also you can expect this type of question. Identify A, B, C in the following. Ready? Let us start. First compound is given. What is C6H5OH? That's nothing but phenol. Right? Phenol. What is NaOH? You know, first when you treated with the NaOH, we get sodium phenoxide, right? Sodium phenoxide. Then they are treating with the carbon dioxide. Then they are treating with the what? Acid hydrolysis. You know what is this reaction called? Kolb's reaction. We get OH and COH. You will get salicylic acid. So our compound A is which one? Salicylic acid. What is the next reaction? Next reaction treating with what? CH3COCl. We are treating with acetyl chloride. What is an acylation? You know, acylation takes place on alcohol forms ester. So this H, this Cl cut, you will get benzene with acid is there without any change. It become OCOCH3. You will get the aspirin, acetyl salicylic acid. So this is your compound B, that is aspirin. Next step is treating with the bromine in presence of Fe or FeCl3, FeBr3, some catalyst also they will mention. That is our electrophilic substitution. So bromine is coming to the ring. So where it get attacked? You know, alcohols are ortho-para directing group. So with respect to the OH dear, which is the ortho, this is the ortho, this is the para. And what is acid? Acid is a meta-directing, it is a deactivating group. Only for bothered about which one? The activating group, that is our ortho-para-directing group. In this ortho-para-directing group, dear, where the Br can attack, what do you think? Either it can go to this side or it can go to this side. Which is best? I will select this part because it's para. Para is what? Major product, right? So keep the OH and COOH there itself, and Br comes to the para position. That will be the major product, and that is your compound C. Clear? So that is the compounds A, B, C in the following reaction. So hope you get it. What are the questions they asked from the chapter? Alcohol, phenols and ether, dear. Practice well.